Alright, let's look at the homework 8, problem number 5. Alright, so we have this rational function given, and we're going to answer a bunch of questions. Alright, so summarize the domain. So we have to look at the domain. Alright, so we don't want the denominator to be 0. So we can look at the x squared minus 16. We don't want that to be 0, so not equal to 0. Alright, so 16 is 4 squared, so we can factor it out as x plus 4 times quantity x minus 4, and we don't want that to be 0. Alright, so we know that we cannot have x equals plus or minus 4. Alright, so that's that. So everything but those numbers. Alright, so we have all real x except x equals plus or minus 4. Alright, so we got that. Alright, next we want to find the x-intercepts and the y-intercept. Alright, so here, let's find the x-intercept. Alright, so we're gonna again set y equal to 0. Right, which means that we take the function and set the whole function equal to 0. Alright, but to make the fraction equal to 0, we have to make the numerator equal to 0. So we can simply divide through by 5 to get x equals 0. So x-intercept is 0, and a y-intercept is going to be, alright, and we're going to set x equal to 0, and I think we know the answer, but the y is equal to, if you plug in 0, whole function is 0, so it's 0. Alright, so x-intercept is 0, and a y-intercept is 0. So we have, let's see, 0, 0, so D is the right answer. Alright, check the answer. We got that. Alright, and asymptotes. We want to find horizontal and a vertical asymptote. Alright, so you can see that when x equals positive 4 or negative 4, you're going to have a vertical asymptote. You have a vertical asymptotes at x equals positive and then negative 4. So you have two of them. Right? Then horizontal asymptote. In this case, if you look at the degree on top is 1, degree on the bottom is 2. When the degree on the bottom is higher, y equals 0, which is the same thing as x-axis, is going to be the horizontal asymptote. Alright, so we have that. So let's find the answer. Alright, horizontal asymptote is y equals 0. Vertical asymptote is x equals positive and negative 4. So that's going to be the right answer. Alright, we got that. Alright, then we want to look at the increasing, decreasing behavior. So we're going to take the derivative. Alright, so you have f prime of x, alright, is equal to, alright, so another quotient rule. So you have quantity x squared minus 16 squared, square the bottom. Alright, I'm going to put the 5 in front, and derivative x is going to be 1 times the denominator is x squared minus 16 minus top is going to be 5. Remember that the 5 is already out here, and times the derivative of the bottom, which is 2x. Right? So if you clean it up, you're going to have 5 on top, which is this guy right here. All right, then you have let's see, you're going to have a negative 6, or actually minus 16 there. All right, so you're going to have a minus 16. And then we're going to have, let's see, x squared minus 2x squared. So it's going to be a negative x squared, right? And over x squared minus 16 squared, right? Since we have a negative sign on both terms, I'm going to pull the negative sign out. So you have a negative 5, and then you have x squared plus 16 over quantity x squared minus 16 squared. All right, and if you look at this, and you can see that this guy is always negative, because you can see this portion right here is always positive, and because of the square, this guy is also positive. Right, so it's always negative, which means that the original function f is always decreasing. Right, so let's choose that. Right, of course, except for positive 4, x equals positive 4 and negative 4. Alright, so it's decreasing. Here you're eliminating negative 4 and positive 4. A is the correct answer. Alright, so we got that. Alright, and we're going to look at the let's see, local max and local min. So let's look at the behavior. So since this guy is always decreasing, there is no local maximum and a local minimum. So there's no local extrema. Check that. We got that. Alright, then we're going to look at concavity. Alright, so we're going to take the derivative one more time. So we take f double prime of x. Alright, so we have this. So I'm going to square the bottom. So you have x squared minus 16 to the 4th power. Alright, then I'm going to put the negative 5 outside. Right, derivative at the top is 2x multiplied by denominator is x squared minus 16 squared minus top would be x squared plus 16 times derivative of the bottom is 2 in front, and then you have x squared minus 16, subtract 1 from the power, so you got first power, and then multiplied by derivative inside, which is 2x. All right, now we need to clean up a little bit. All right, so this is going to be, all right, so you have a negative 5 is there. All right, so denominator looks okay, so I'm going to just put the denominator, quantity x squared minus 16 to the 4th power. All right, let's look for the common factor. So we took care of this, and we took care of that. Alright, so both of these terms have 2x. Alright, so I'm going to put 2x once. Right, there's no point of writing the same thing twice. Alright, and then another one here, you have x squared minus 16. So you have actually 2 of those, so I take one of them. Alright, so you have x squared minus 16. Alright, and then what's left is going to be, alright, so I'm gonna, leftover would be x squared minus 16, that's from here, alright, then we're gonna have, let's see, 2 times that, so it's gonna be minus 2x squared minus 32. Alright, so we have that. Alright, then we can cancel x squared minus 16 here. You have 4 of those, so you reduce that to 3. Alright, then you can clean up this part of it. Alright, so you have negative 5. Alright, so you have x squared minus 16 cubed, right? And then you have a 2x here, right? So this is going to be negative x squared and a minus, let's see, 48, right? Since you have both of these negative, so I'm going to incorporate this negative sign to turn everyone into a positive sign. Alright, so we have that. So it looks like if you clean it up, you're going to have 10x x squared plus 48 over, alright, x squared minus 16 cubed. Alright, we're going to have to do a number line. All right, here's a number line. All right, so we're going to have to put, if you set that equal to 0, you can see that x equals 0. So x equals 0, you have to put that on. And also you have a vertical asymptote at -4 and a +4. +4 I meant. All right. Then we're going to look at the sign of the second derivative. All right, so it's a lot of work. All right, any number less than -4. So I'm going to try -5. All right, so you have a negative number here. And the -5 minus 6, so that's positive. So you have a negative sign here. All right, because this part is positive. All right, we're going to try x equals -1. I have a negative number here, that's positive, -1, so it's going to be 1 minus 6, so that's negative, cube is negative. So you have a negative divided by negative, so you actually have a positive sign here. All right, we can try x equals +1. So this is positive, and that's negative, so it's going to be negative there. All right, we can try x equals 5, so it looks like everyone's positive, so you have a positive sign here. So you can see that the original function, concavity-wise, it's going to start out concave down, and then concave up, concave down, and a concave up. All right, so let's type it in. All right, oops, here. All right, so we're going to have a concave, start out with a concave down. So here, and not this one, concave upward. Let's see, not this one either. Let's see, concave downward on, let's see. Let me see this one. All right, so we're going to have a concave down, up, down, up. Right, so do you have that choice? Okay, so concave downward, and then here 4 and infinity. Concave upward on a -4 to 4. That's actually not the case. Let's see. We're gonna see if oh, actually, I didn't know there was a choice. Let's see. This is the one. All right, good. All right, found the answer. All right, we got that. All right, and then inflection point. All right, so you want to find an inflection point. It could be, it's a -4, a 0, and 4. But you can see that the function is not defined. So here, there is no inflection point there, and here there is no inflection point there because function is not defined. But here we're going to have an inflection point. So we have at 0, inflection point at 0. All right, do that. All right, we got that. All right. So let's see. So it has to be always decreasing. So that this one. So this is always decreasing. Not this one. Not that one. So we know that since we know that it's always decreasing, B has to be the answer. All right. Got that. All right. That's it. I hope that this was clear.